All right. It's Tuesday, February 8th. We're going to be taking our final set of notes on 5.3. Realize we've been dealing with 5.3 for a long time, but graphing quadratics is very complex. And it's a complex skill set with a lot of required knowledge, okay? We will have a major quiz on graphing quadratics this Thursday. That's 2 days from today. Okay, so let's go to work. I've moved all the way back to here in our notes. You've already taken this, okay? We've had quizzes on this multiple times. The first up there is standard form. F of x equals ax squared plus bx plus c. When we talked about graphing things that were in standard form, what was the first thing we talked about? Thank you. Everybody's so loud today. We talked about the junk in the trunk, okay? Or the, more specifically or mathematically, this is the linear term. If there was no linear term, that made it very easy for us. For example, maybe we had y equals 2x squared plus 3. No linear term there. Well, we know that our constant always tells us our y-intercept. But when there's no junk, not only is the y-intercept, but it is also the vertex. Everything I'm saying here sounds familiar to you? A lot of nodding of the heads. That's good. All right. However, if we did have a linear term, what did we need to use? We needed to use x equals negative b over 2a. Everybody remember this? For example, if I had f of x equals x squared plus 2x plus 3, I would have to then go x equals the opposite of b, which in this case would be a negative 2, over 2 times a, which in this case is 1, to give me a negative 2 over 2, which reduces to a negative 1. Then I would have to take that negative 1 and plug it back into the function. So I'd have to find f of negative 1, which would be negative 1 squared plus 2 times negative 1 plus 3. So negative 1 squared is 1. 2 times negative 1 is negative 2 plus 3. 1 minus 2 is a negative 1 plus 3 is a positive 2. This all tells me my y value. It goes with my x value to get my vertex, which is negative 1, 2. That's a lot of work. I know. You didn't like it. Okay? And technically, I'm not done with the work because technically, I got to graph that vertex, and then I'm supposed to do a t-chart and pick 2 more points and plug those in, right? And then mirror them across. Are we having a good mental exercise refresher here? Yes? Okay. That's all fun. And then, after all that work, which we didn't really like that much, we went on and learned about vertex form. We liked vertex form, didn't we? Vertex form is very simple. Say I had f of x equals 2 times x plus 3, quantity squared, plus 4. What is my vertex? Wow. I don't know if you could hear that on a video, but everybody was answering negative 3, 4. It's almost like we can just look at it and we can see this number, take the opposite of that one. So negative 3, and then look at this number, and that's my y value. Yes, that's right. I can actually just look at it and see my vertex. Now I can plot that vertex, negative 3, 4 here, and then I can do what? I can look at my a. And from there I can go up 2 over 1, up 2 over 1, and I've graphed so simply and so easily. Yes? Oh, we like vertex form, right? We like vertex form. What about this last one? Intercept form. Intercept form. Let's say I have f of x equals x plus 2 times x minus 3. How do we do that one? Well, we know this is called the intercept form or the factor form. We know our two X-intercepts. X-intercepts, just by looking at it. It's going to be negative 2 and a positive 3. Remember, this negative sign's in here means we got to look for the opposite. Got to take the opposite of it. So in other words, if I were to graph this particular one, it would cross the x-axis at negative 2 and 3. Yes? Then what do? Well, we find that midpoint. 1, 2, 3, 1, 2, 3, 4, 5. It's 5, so 2.5. Picked a bad number, but anyhow, there's my axis of symmetry, the exact middle between those 2 points. Okay, which in this case is 1/2. And then I find the function at 1/2. So I have 1/2 plus 2 times 1/2 minus 3. So this is 2.5 times a negative 2.5. Anybody get a calculator on them? 2.5 times 2.5, go. I'm waiting. Do 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 do. It's a negative 6.25. So way down here at negative 6.25 is my vertex. Okay, so that's what we've learned here in unit or section 5.3. That's a lot of stuff, isn't it? That is a lot. That's why we spent so much time on it. Okay. The next thing we're going to do from here is we're going to learn how to manipulate these equations to change them from one form to another. And we're going to start by, the very first one we're going to do is going to be going from standard form to intercept form, and it's called factoring. Okay? It's called factoring. That's where we're going to get the end of the week and early next week. We're going to teach you how to factor. But before we get there, I want to make sure we're really, really good at graphing. Okay? Your first warning is you have a quiz, a major quiz, a 100-point quiz, not tomorrow, but on Thursday. Okay? Not tomorrow, but on Thursday. All right. So we should be on section 5.3. I want to go through this again. I want to take our time because we're trying to have mental exercises here and make sure we're good at this stuff. Okay? It may almost seem comical to have a whole new section on how to graph quadratic functions. After all, we're familiar with graphing functions in general. There's nothing really new about the process of graphing for quadratics. Determine some appropriate inputs to use, get the outputs, graph the input-output pairs on a coordinate plane. In other words, make an XY chart or a T chart. However, there are new parts of a quadratic graph itself that we want to look at. Graphing quadratics in standard form, or the standard form of quadratics, is f of x equals ax squared plus bx plus c. Notice with that squared term, we won't want to pick out very large numbers. Otherwise, we'll end up off of a typical coordinate plane, 10 by 10 coordinate plane. Typically speaking, we recommend using inputs between -2 and 2, right? So let's start with the simplest form of the quadratic. F of x equals x squared. Does anybody know the nickname of that particular one? At this point, we should know it is the parent function. Why is it called parent function? A parent function is always the simplest form of the function. For example, the linear function, the parent function of a linear function is y equals x. Okay? All right. So if we chose f of x equals x squared and we plugged in -2, -2 squared is 4. -1 squared is 0 squared is 0. Everybody, 1 squared is, and 2 squared is. See how we get those inputs and outputs. We've done those t-charts before. And if we were to graph those points, -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4, notice the U shape of the quadratic to the right. This is called a parabola and is the shape of a quadratic function. And it's why it's important to choose good inputs. Many times with quadratics, you'll only get half of the picture if you're not careful with the inputs that you choose. For example, consider we use the function x squared plus 6x. If we make the same input-output chart using -2, -1, 0, 1, and 2, we would get these outputs. -2 squared is 4. 6 times -2 is a -12, so 4 plus a -12 is a -8. See how that worked? Anyhow, we get these outputs. If we were to graph those, -2, -8, -1, -5, 0, 0, 1, 7. Look, we only get half of the parabola, Austin. It's amazing how that happens. Because you don't choose necessarily the appropriate inputs. At this point, it just looks like a curve rather than a U-shaped graph. So to get the full picture, we want to keep trying inputs until we get the quadratic shape. So we need to use these numbers that are on the other side, like -4, -5, and so on. So if we plug those in to the equation, we get -5, -5. We get -4, -8. Now we can see the U shape of the parabola. Now we get the full picture. I knew to go further to the left based on the direction of the curve that we had seen so far. It looked like to the left it was beginning to flatten out, making what we had the right half of the U shape. Moral of the story? Pick good inputs. How do you know where to start if it's in vertex form? How do you know what are going to be good inputs from this formula? X equals -b over 2a. Does anybody remember where this came from? The quadratic formula. -b plus or minus square root b squared minus 4ac all over 2a. That's the quadratic formula, which you're going to have to learn pretty soon. Try it with me. -b. That you repeat that. Let's try it again. -b. Everybody sing after me. -b plus or minus square root b squared minus 4ac all over 2a. Wow, I'm going to have to call your choir teachers. Not real. I never did choir. All right. Good inputs output the vertex and the zeros. Good inputs. Excuse me, gentlemen. Might want to focus. How do we know if we have good inputs? Well, ideally to know where the vertex is. What's the vertex? The vertex is the point at which the maximum or minimum of the parabola is. Here on the one given to us on the right, that vertex happens to be the minimum. Also known as the turning point of the parabola, when it changes from decreasing to increasing or vice versa. It's also useful to know the zeros, where the zeros are, if there are any zeros. You know it's possible to have a quadratic with no zeros? What's another name for zeros? Solutions. Another name for zeros. X-Intercepts. One more name for zeros. The roots. The roots of the quadratic. Yeah, that's what I'm after. Okay. The zeros are the points where the parabola crosses the x-axis. They're also known as the x-intercepts. Check out these three graphs. This first one has 2 zeros. That's what we deal with most of the time. Okay? I want to be a little bit more specific. What is this zero? What is the value of that zero? Yeah, it's 0. What's the value of this zero? -6. So this particular one, I know that my function is going to look something like this. X plus 0 times x plus 6. I wonder how many of y'all just caught or were able to pick up what I just laid down there. I can see 3 of you that don't have a clue what I'm talking about. This particular one, the second one, has only 1 0. And that's the vertex. Why does it only have 1 0? Because it only touches the x-axis one time. What about this one? It has no real zeros. Let me say that again. It has no real zeros. This class is about to get turned upside down, and you're going to learn about something about imaginary numbers. That's right. Imaginary numbers. We're going to bring in a whole nother number system that you've never used before called the complex number system.
You can use normal ones.
Then I guess you better catch up. And to deal with those imaginary numbers, it's going to be when we have problems like this. Okay, it'll have imaginary solutions. It'll be interesting. It'll be fun. Notice that if we knew where the vertex and the zeros were, we could do a quick sketch of the graph fairly easily. Say, for example, we know that the graph is a parabola. How would we know that the graph's a parabola in the first place? How in the world are we going to know an equation is going to give me a graph that's a parabola? At this point, every hand goes up because everybody knows that if it's a function to the second degree, it's a quadratic function, right? And every quadratic function has a graph that is a parabola. Just like we know that every linear function, what's a linear function? It's a function to the first degree. We know every one of those gives us a straight line. So we know if we have a quadratic, the graph is a parabola. If we know the vertex is 4, -8, 8, and we have zeros at 2 and 6, 2 and 6. Now we can sketch that parabola as follows, or as seen there. This is exciting stuff, yeah? There's a lot here. A lot more. I mean, just looking here at these pages that are going across your screen, look at all the different things that we've talked about as we've dealt with this stuff. It's a lot. We've done a lot of work. Those of you who have kept up You're amazed, should be amazed at how much you've learned with quadratics. I want to take and I want to graph 2 of each of these. I know that you've already done some of this homework, okay? But go to these numbers and let's look at them. See how quickly and easily we should be able to graph these now. Okay, number 1 here. Number 1. Now, this T-chart's here because I'm really supposed to pick inputs, right? And plug them in. But before I do that, I can see that this is in which of our 3 forms? Standard, vertex, or intercept form? And everybody said? Intercept form. So I know right away that my intercepts are going to be -2 and a +4. In other words, this thing's going to cross right there and right there. Does everybody see it? So watch this. I'm going to choose those as 2 of my inputs. I'm going to choose -2 and 4. Guess what I already know for about those 2 inputs? I already know their zeros, or their outputs are 0. Isn't that amazing? Huh. Never really thought about it like that, but that's what every ordered pair is, right? It's an input and an output. Now, I need to find my vertex because that's my other point that's very important to me. And I know my axis of symmetry is going to be exactly in the middle between those 2 points. So I got 1, 2, 3, 4, 5, 6 points between those 2. So half of that would be 3. So 1, 2, 3. So right there at 1 is going to be my axis of symmetry. Guess what other input I'm going to put in here? That's right, 1. Any other inputs we want? Well, I'll put in 0 just for fun and 2 if I want. Now, I do have to find f of 1. But I got to plug it in here. I got 1 plus 2 times 1 minus 4. Well, 1 plus 2 is 3. And 1 minus 4 is -3. 3 times -3 is -9. -9. There it is. Now, let me ask the question. Let's see how many of you are actually keeping up with this. Do I actually have to put in 0 and 2 to find my outputs? Why not? Somebody? Why don't I have to put them in? Because I can just go, I can use my A value, right? What is my A value in this thing? It's 1. I can go from that vertex up 1, over 1, up 1, over 1, and there's my 2 values. So what are those other 2 outputs? -8 and -8. So I did a lot of work there, but not really. It was actually pretty easy to do, wasn't it? Now, I showed every little step there. I'm going to do number 2 the same way. I'm going to do the exact same thing, just a lot faster. How many of you feel good about number 1? Ooh, how many don't feel good about number 1? So I guess you're somewhere in the middle. Like, all right, here we go. My intercepts are -6 and -8. So -6 and -8. The exact middle of that would be -7. I'm going to move these over because I can see them really close. So that gives me 0 and 0. -7, f of -7 is -7 plus 6 and -7 plus 8, which is -1 times 1, which is -1. There it is. I don't really need any more points, but I'm going to do more just for fun. Okay? And I'm going to do -5 here. F of -5 is -5 plus 6 times negative 5 plus 8. Negative 5 plus 6 is 1. Negative 5 plus 8 is 3. 1 times 3 is 3. Watch this. So I got negative 5, 3. Anybody want to tell me what negative 9 is going to be? How do you know? Yeah, it's a mirror of the other side. So I really don't have to do the other one, do I? Really don't have to plug it in. Cool? By a show of hands, how many people want one more that looks just like that one? You're good. All right, so if I have a quiz tomorrow and I give you two that are in intercept form or factored form, you're going to be able to graph them, give me 5 points, just like this. Awesome. Yes? One person, raise your hand. You don't feel good about it, and I'll do one more. All right, move it on. Let's look at number 3. What form is number 3 in? And everybody said standard form. Not only is it in standard form, but it has junk in the trunk. So before I even begin, I got to go negative 6 over 2 times a, which in this case is 1. That's negative 6 over 2, which is negative 3. Negative 3 is my starting point. It's where my vertex is going to be. Okay? Now the next 2 points I'm going to use are going to be negative 2, negative 1, negative 4, and negative 5. Do I understand how I chose those points? Okay. Now I have to do some work. I got to find f of negative 3. Okay, so I got negative 3 squared plus 6 times negative 3 plus 2. Well, negative 3 squared is 9. 6 times the negative 3 is negative 18 plus 2. 9 minus 18 is a negative 9 plus 2 is negative 7. Negative 7. Everybody good with that work? Because I'm about to erase it. 3, 2, 1. Sorry, I have to erase it, though, because I need to plot that point. Negative 3, negative 7. Now, what's negative 2 going to be? Now, I could plug that in and do the work, but I'm not going to. I'm going to use my A value. My A value is 1. I'm going to go up 1, over 1, up 1, over 1. That gave me my next 2 values, which is negative 6. Let's plug in negative 1, f of negative 1, to get negative 1 squared plus 6 times negative 1 plus 2. So I got 1 minus 6 plus 2. 1 minus 6, negative 5. Negative 5 plus 2, negative 3. Negative 3. Negative 3. See, I just mirrored it across. There is my parabola. Cool? Questions? Let's find another one. Number 8. Number 8 looks good. All right. It's in standard form. It has junk. Therefore, I've got to use 6 over 2 times 3, which is 6 over 6, which is 1. Okay. 1. I'm going to go 2 and 3, 0, and negative 1. I'm going to use my knowledge here. Stay with me. Some knowledge I already have is this negative 3 here. What is that negative 3 tell me? My y-intercept. My y-intercept is going to cross right here at negative 3, and my x value there is, down here, negative 3. My x value there is 0, isn't it? Right? And that's 1 point right beside the vertex, isn't it? I know something about that point, the relationship between that point and the vertex point, don't I? From the vertex to get there, I would have to go up 3 over 1, right? So here I can go down 3, 1, 2, 3, and over 1. Hey, there's my vertex, isn't it? Huh. My vertex then is -6. Gee, I wonder what my value is going to be at 2. Yeah, it's going to be -3 as well. Look at all the things that I found, and I really didn't do any work, did I? I don't really need any more points, but we're going to get one just for fun. F of -1 is 3 times -1 squared minus 6 times -1 minus 3. Well, that's 3 plus 6 minus 3 is 6. 3, 6. -1, 6. There is my parabola. How many feel good about ones that are in standard form? A lot more hands than the last one. I like that. The last one we're looking at is Vertex Form. That's our favorite one. Vertex Form. The first one was in Vertex Form is number 4 here. I can find my vertex really easily, opposite of what's inside and on the outside. So I got 6, 2, 6, 2, 6, 2. I just said it 3 times and I did 3 different things. Don't worry, I'm here all week. Unless, of course, we have a snow day. Anyhow, moving on. So I need to choose other values. I'm going to choose 7 and 8 and 5 and 4. I can find my 5 and 7 really easily, can't I? Use my A values. Go up 2 over 1. Up 2 over 1. So those values are 4 and 4. How am I going to find my other point? Anybody? How am I going to find the other points? I'm telling you on your quiz, you're going to have to give me all 5 points. So what do I have to do now? I got to plug one of those in. I don't have to do both of them. I just got to do one. So I'm going to plug in 4. Let's find F of 4. That means 2 times 4 minus 6, quantity squared, plus 2. All right, work inside out. 4 minus 6 is a -2 squared plus 2. -2 squared is 4. 4 times 2 is 8. Plus 2 is 10. So 4, 10, and 8, 10. Not so bad, huh? Yes? You're good with that? Last one. Let's look at number 9. Number 9 is also in vertex form. My vertex really quick. -3, 6. I like it. -3, 6. -3, 6. There it is. So I'm going to choose -2, -1, -4, -5. I can use my A value, which is -1, down 1 over 1, down 1 over 1, to have -5, not negative, +5 and a +5. Now I do need to plug one in, so let's go ahead and plug in -1. F of -1 equals -1 plus 2, quantity squared, plus 3, quantity squared plus 6. So -1 plus 3 is a -2. -2 squared is 4 plus 6. Now notice that this negative sign is just sitting out there on the outside, right? So this is really a -4 plus 6, which is 2. Good? Questions, comments, concerns? If you can do all of that, you are in great shape. That all makes sense to you? You can do all that? You've learned a ton. If you haven't, or if you can't, you've got 2 days to get it figured out. Got it? Got it, get it, good. And let it roll.